Yes?
Have you thought about churches? I mean, here in the Southeast, that would be a big...
We did think about churches, and this is a really, it's a touchy one to deal with, because there are certain religions who are more or less open to letting people come in. And we were really cautious about wading into the conversation about one religion being less open than another sort of thing. Churches are certainly places at times, places of worship, I should say, are certainly places where there is somewhat of a tolerance for allowing people to come in and get refuge, people who are in need. So those are captured in the indices that I showed. But we tried to not enter into a dialogue or discourse about what it means for certain denominations or certain religions to be more or less open. It's in there though. We got into this at mosque versus church versus synagogue. I had hours of conversations with one of my students about how we talk about this, and we said very carefully.
So,
was there a follow-up there? Go ahead.
Was there a follow-up? No. Okay. How can you talk about the differences between how perhaps foreign cities might deal with heat refuge access? Like I know Paris has had issues with that in recent years. Is there any similarities, differences?
I don't know the answer to that question. Yeah, that's a good question. The only relevant thing I can say to that is that there's a very interesting acclimation is the better word. It's really interesting when you look at heat effects, negative heat health outcomes, morbidity, mortality, to temperature rise. Because in a place like Phoenix, where it's really, really hot, the temperature has to actually go up a lot before you have a lot of negative health outcomes. Unlike a place where LA, where the temperature is milder, and it only needs to go up by a little bit, and you have a lot of negative health outcomes. So there's some sort of acclimation that happens, which I would speculate is a function of both, the people who live there, the behaviors and activities that they undertake, as well as the characteristics of the infrastructure, right? All of those things, right, come together. When you look at heat waves like in LA that have happened in the late 2000s, it doesn't take much to get the same number of deaths as you see in Phoenix when the temperature has to go up a lot more, sort of thing.
okay, so when you talk about the Phoenix road flooding and the bridge replacement that Caltrain did in three weeks,
Yep.
did they replace the bridge with an identical structure?
Good question. I don't know the answer to that. Did they use a 1 in 100 year return period? Great question. So when you design, I'll give you guys another example. When you design your asphalt mixture in Arizona, the Arizona DOT for those infrastructure, interstates and highways, require you to spec your asphalt mixture based on the 1 week high that occurred between 1970 and 1990. They will give you a spreadsheet, you can download this spreadsheet, where you have all the temperature highs over those 2 decades, and you are supposed to find the hottest time period in there, which was some week or 2 in there. It's hotter now, there's no doubt about that. We can look at actual temperature measurements. Not only that, when you look at global climate models, it's probably going to be hotter in the future, right? So what's happening now? Connect the dots, right? What's happening with asphalt? Anybody want to take a guess?
It's starting.
It's breaking down. It's, rutting, cracking, all of the mechanisms of failure for asphalt. And I have spoken with Arizona DOT, and there's a few bright lights there, people who basically realize what's going on, and they say to me, yeah, I think our engineers are thinking that the construction guys didn't do a good job, and asphalt is not lasting the 10 to 20 years that it should last. It's breaking down in like 8 to 15 years, well before the lifetime. And they're going in, and they're resurfacing, again with the historical temperature mixes. And you know, I don't think that there's this sort of systematic thinking that's going on. So there's a few bright lights in these agencies, but this is a phenomenally interesting question which we're getting at the SRN. Infrastructure are socio-technical systems, right? So infrastructure are not just a bunch of physical things. Infrastructure are institutions and people and rules and policies and norms. And resilience, right, to fix this problem that I've been mentioning, or the problems that we've been talking about, is going to require somebody to go in, recognize that this is a problem, at the very least look at temperature today, hopefully take some temperature forecasts, right, so we're not building infrastructure that's going to break down in future heat. But go in and basically say the requirements for upgrading this infrastructure have to change. My speculation is that that did not happen with this, although that's just speculation.
It also kind of makes you think about building codes. I mean,
Yes.
and how they need to be updated.
That's right.
And, you know, there's passive cooling techniques that can be designed in buildings, or you have solar panels, and you can off the grid, and
Yeah.
sort of that
So one of the
safety.
Yeah, exactly. One of the things that we've been doing in my research lab is we've been taking equipment, typical infrastructure equipment, so you know, transformers and water pumps and asphalt and stuff like that, and you look at the rating of it. So when a power company decides to, your power agency decides to put in a particular infrastructure piece, they have a choice of rating here at one cost versus a rating over here at another cost. And what they do is, you know, they've got a budget and they've got, you know, how things have been, and they basically pick something, right? So we've been looking at what they typically pick. And the ratings tend to be at the upper end, you know, right in this gray area of where you're, you know, probably going to see temperature being exceeded in the future. So for example, a transformer that we typically see being installed in Phoenix, it's one that's functional between 30 degrees Fahrenheit and 120 degrees Fahrenheit. And you know, the forecasts that we're looking at see, you know, many of them pushing past 120. By the way, no humidity in Phoenix, so you guys have like humidity here. 100 in humidity, I don't know, we can argue about this all day, is bad. 120 with no humidity is also bad. So a lot of people say, well, there's no humidity, so it's not that bad. It's bad. It's bad. You want to know what it's like, just like take a hairdryer and point it at your face. So we take these rating of components and we derate them. So we've done these probabilistic models that was mentioned before, and we look at how much, so we derate them, and then we basically look at a probabilistic curve of what you might expect on their lifetime. And you can see that the mean time to failure, when you derate them, reduces, meaning that it's not going to last as long. So something that you might have picked that in the past would last like 30 years is probably now going to last like 20, 25 years, right? So, you know, that's where you get into these questions of, well, you know, what does it take to put in, you know, the bigger one? What do the codes look like? And so,
All right, we would like to take more questions, but we just can't.
thank you
So
all.
please go ahead.